Hi everyone, welcome to my session at PulumiUP. Today we're going to be having a look at the Pulumi operator and how you can use that to move to a more GitOps type approach for deploying your infrastructure and hopefully make things a bit more streamlined. My name's Sam Kogan. I'm a solution architect with a company called WTW based in the UK, and I'm also a Microsoft Azure MVP. And I spend a lot of time building and talking about infrastructure as code, cloud automation, deployment management, and those sort of things. And in today's session, we're going to delve into one of those areas where we're going to have a look at how you can take a more of a GitOps approach using Pulumi. So just as a quick reminder, or if you're not familiar with GitOps type approach to deployment, GitOps is a method of deploying resources where you use a Git repository as your source of truth. So it relies on you having a declarative means to define your infrastructure, so some sort of infrastructure as code methodology, and primarily, at least when it started, it was focused around deployments to Kubernetes. So you had Kubernetes YAML files stored in a Git repo, and you then configure a GitOps operator of some sort inside a Kubernetes cluster, which is going to help you manage that. So there are several tools on the market for that. The two most popular are Flux and Argo CD. And the way the system works is effectively you commit all of your Kubernetes files into a Git repo. You have a process using pull requests and merging those to manage changes to that. And when a change is made to the Git repo, there is a webhook called on Flux or Argo or whatever tool you're using, which recognizes there is a change, and that tooling then reconciles the change in the Git repo to what's actually deployed in your Kubernetes cluster. And it does this on a continuous loop so that it's always comparing what's in Git to what's actually deployed in the Kubernetes cluster to deal with things like drift and so on. And it means that now people aren't manually deploying things, people aren't running things directly against the cluster themselves. The whole process of making changes to your infrastructure is to make a change in the Git repo, either add some additional YAML files or make changes to existing ones, go through a process to commit those, maybe go through pull request review, testing, whatever, merge those into your particular branch that's managing your GitOps approach, and then that will then trigger Flux or Argo or so on to then deploy those for you. So your Git repo represents exactly what is deployed in reality. And because it's got that reconciliation loop, even if somebody makes some manual changes, you should always go back to your source of truth within the near future when it comes and does that loop and notices that something is different. So as I said, primarily, this has been focused on working with Kubernetes resources. However, using the Pulumi operator, we can take a similar approach, but instead of having Kubernetes YAML files, we've got Pulumi files, one in whatever language you choose to use for that. And that opens up the whole approach to being able to deploy resources, not just to Kubernetes, although we can still deploy to Kubernetes, but to any of the providers that Pulumi supports. Now, the Pulumi operator works in a similar way to Flux or Argo in that it is deployed to a Kubernetes cluster. So you do need a Kubernetes cluster to run this operator to actually manage your resources. But what you actually deploy doesn't have to be in Kubernetes. It can be in any of the providers. And the operator is what's sat there waiting for webhook requests from your Git repo to tell it there's been a change. And it's the thing that's running that reconciliation loop to make sure that what is in Git is exactly what is deployed into the real world, into whatever cloud provider or other provider that Pulumi provides. And so by using the Pulumi operator, if you're already invested in a GitOps approach for Kubernetes, you can move to using the same approach for all of your infrastructure. Or if you don't use GitOps at all, but you're interested in going forward with that, you can start straight out of the bat with using Pulumi. And so your infrastructure as code can then support anything that Pulumi supports. And getting started with this is fairly simple. What you're going to need is a Pulumi project to deploy your infrastructure that you perhaps already had. So there's nothing special there. You need to write your Pulumi code to deploy whatever infrastructure you want. We'll need to deploy the Pulumi operator onto a Kubernetes cluster of some sort. And then we will need to get the actual Pulumi code into a Git repo and join all these things up so that the Pulumi operator is able to pull the code from your Git repo and then deploy it into your cloud provider. So let's have a look at how that all works with a few demos. Okay, so the first thing we need to do is to actually deploy the operator into our cluster. So this is the infrastructure that's going to actually do the reconciliation loops and deploy our Pulumi resources for us. And there are two ways we can do that. You can use kubectl and deploy it as custom resource definitions directly from a Git repo that Pulumi provide. That's one way to do it. Or alternatively, you can use Pulumi to deploy it. So we're going to take the Pulumi route and we're going to use that to actually deploy the resources onto our existing cluster. If you look at this section, it gives you basically a Pulumi template to use to create your project, which will have all the things you need configured with it. So you basically need to decide which language you're going to do. So you've got .NET, Go, Python, or TypeScript there. We're going to use .NET and just copy that section. And you can see down here in the example, it gives you the full URL. So you're going to do a Pulumi new command with that URL and stick your template on the end of it. So we're over in our CLI and we're going to run that command. So we'll do Pulumi new and then paste in that GitHub URL. And what that should do is it should go off and fetch that template from GitHub and then walk us through creating the actual project. So we can take the default operator, that's project name, that's fine, and then that's fine. And we'll create a stack for this. I'm just going to call it operator dev. And this should now go ahead and create that project for us. It's complaining about some dependencies, which I will deal with in a minute when I run .NET Build. It should sort that out. So here we are with this project open in VS Code, and you can see the issue here is complaining about, for some reason, the template is set to use .NET Core 3.1, which is obviously a bit old. So we're just going to change that over to use .NET 7, and that will fix that compilation problem. If we take a quick look at the stack, and look in the stack file here, see we've got a program created for us, and there are a few things in here that we can configure to customize this. The first thing is it's got the versions to use for the custom resources, and we can alter those if we need to, but they should be fine. And then you can see it's pulling those CRD definitions from GitHub when it actually runs. And then we've got some information we are setting around namespaces. So you can set or deploy the operator into one or more namespaces to then reconcile resources that go into those namespaces. And you can set that through the config file. If you don't set anything, then it'll be set to default. But we're going to customize that in a moment to use our custom namespace. And then the rest of the code is basically going through and deploying those operators, which you don't really need to care too much about. But if you're interested, you can have a look through and see how that's all set up. And it's creating all those operators, role bindings, and so on. But we should be good to deploy straight away with that. If we want to use the default namespace, we're going to make a quick change just to use a different namespace. So over in our CLI, we can use the Pulumi config command. So we're going to set the value of namespace to, let's call it Pulumi operator. And that will create a config file for our current stack and put that value in it. If you wanted to have multiple namespaces, you would basically set the command using this. So where you have a namespace array, you could do it that way. Or obviously you could edit the config file directly. So if we have a quick look back in VS Code, and we should see now we've got a Pulumi.operator dev, which is our stack we created. And you can see here we've got the namespace one that we set up before. We're going to go back to our CLI and we're going to run this. So this is, as you saw in that file, there is no Kubernetes provider set up. So it's just going to use the default provider, which will use my kubectl I have on my machine to deploy it. You can obviously amend that file to set a explicit provider, give it connection details and authentication details to be able to connect to whatever cluster you want. For the purposes of our demo, we're just going to use the one we've got there. And if we have a look on that cluster, we probably don't have a namespace for this. No, so let's go ahead and just create that namespace first. We'll do that manually. We could do that in our Pulumi code, but just to make it quick, we're going to do that here. Did now have that Pulumi operator one. Yep, there we go. Okay, so now we're ready to deploy all that. We'll go ahead and run PulumiUP. And that should go ahead and create that, well, all those resources for us and deploy them into our Kubernetes cluster. So we'll say yes, and we'll let that go off and do that. And we'll come back and see what that looks like when it's finished. Okay, so that's finished deploying now. So if we go have a look in our Pulumi operator namespace and look for some CRDs. Kubectl get CRD. And we should hopefully, yeah, and we see there we've got some of the Pulumi CRDs deployed. So there's a stacks one. What else have we got? Programs. We should see that one as well. Programs, yeah, there we go. So that's deployed the operator successfully. So at this point, the cluster is ready to go in terms of deploying resources, but it doesn't have any resources configured on it yet. So that's our next stage to look at, is how do we actually configure a Pulumi stack to be deployed by the operator. Okay, so now we've got the operator running, there are a few other things we need to set up before we can start deploying some resources. And the primary thing here is that our stack deployment in the operator is going to need to know how to connect to various resources. So in my case, I need to be able to talk to Pulumi Cloud to store my state, and then I also need to be able to talk to Azure to do the actual deployment, which is where my cloud resources are going. If you're using a different cloud and so on, you'd obviously use whatever comes from those clouds. So what we've done is we have created a Kubernetes secret that's going to store that information that we're going to be able to access later from the stack when we set it up. So I've done this in Pulumi in the same project that we used to deploy the operator. You can see here I've created a secret object, and within that I've added a number of secrets where the values are coming from the config file. Obviously for the secret ones I've encrypted those using the secret encryption in Pulumi. You don't have to use Pulumi for this. If you wanted to deploy these as plain old Kubernetes secret using Kubernetes YAML, you could do that as well. However you prefer to get them onto the cluster. You also don't have to have them in this way. So when we come to do the stack, you can do things like hard coding the values, pulling them from other places. This is just the easiest way we're going to use here is to pull them from Kubernetes secrets. So they're all in one place, and we can update them for various different stacks if we need to use them. So I've added the actual secret in here, as you see, is a resource with a name and put it in that same namespace as the operator. We've then updated the actual config file to put those values in. You can see I've encrypted the passwords in there, and that is pretty much ready to go. So I've deployed that, and if we go back and have a look on our cluster, and we have a look at get secrets, you can see we've got a secret there, the Pulumi deployment creds, and that's containing all of those details that we are interested in. So that's ready to go. That's going to be used by all of my deployments. Obviously, if you had different service principals or whatever service accounts you're using to do deployments for that you wanted to use for different stacks, then you could supply those however you wanted to in different secrets or additional values in the same secret. You'll see how we reference that in a minute when we get to actually deploying the stack. Okay, so let's get started on deploying some actual stacks. So what we've got first is a GitHub repo, which has got our actual project in it. So this is our actual Pulumi code that's going to deploy whatever resources we're interested in managing through this GitOps type approach. So pretty standard Pulumi project. If we have a look in the actual program file, nothing too exciting here. But basically, this is the default with a few tweaks to deploy a storage account, get some keys out of it, and so on. The standard one you'll get if you've ever deployed using PulumiUP. I've tweaked it slightly so that we are getting the name of the storage account and the resource group from the config file so that we can vary this when we have multiple stacks. And then speaking of stacks, we've created a couple of stacks with the config files you can see here. We've got a K8 and a Pulumi one. And just added a prefix to that we're going to use for naming our resources. That's pretty much all there is to that. So that's stored in Git, and that's going to be our source of truth for where our Pulumi operator is then going to deploy from. So switching back to VS Code, we are now going to define our stack that goes into Kubernetes and runs on the operator. Now, there are two ways to do that. Well, actually, there are more than two ways. We're going to show two ways. You can use Kubernetes YAML files. You can create them as Pulumi applications. And you can even use something like Flux as well for the resource type. We're going to keep it simple today, and we're going to have a look at two options. First, using a Kubernetes YAML declaration, and then we'll do the same with Pulumi code as well if you want to keep everything in Pulumi. So the first one here is this Pulumi YAML file. Standard Pulumi resource. The kind is stack. That's the kind of resource we're looking for. We're giving it a name. And then in the spec, what we're primarily doing here is just setting up some environment variables. And this is how those secrets that we did a minute ago, where we got the credentials that we need for our Pulumi Cloud and for our provider, in our case Azure, are going to get added. So we set some environment refs and give the environment variable name and then the type here. And there's a few different types you can use. Secret here is what we're going to use here to talk to a Kubernetes secret. You could use file to get it off a file on disk. You could use literal to get it actually type it in. And you could also use an environment variable reference as well. You see here we're using the secret type. We're pointing the secret at that secret we created a minute ago, and then the key is obviously which of the secrets you want to use. So we've got our access token, app ID, password, and tenant. And then you can see lastly in here we've got a subscription ID, and this we're not putting in the secret because we might want to vary this based on the stack. We might have one stack that goes in one subscription, a dev stack into a dev subscription, a prod stack into a prod subscription, and so on. We might want to vary that based on the stack configuration. So we're leaving that in here. I've added it as a literal. You could do it any other way you wanted to, but that's what I've added here, and this is for the subscription ID we're going to deploy to. Then the rest of the information here is about how it gets the actual code and stack details. So the first thing here is pointing this at my stack that I've created in Pulumi Cloud. Now, you don't have to use Pulumi Cloud for this. You can use any of the other state backends as well. You could use AWS, S3, Azure Blob, all those sort of things. If you do that, you're going to need some extra settings in here to point it at that state location and give it the credentials and so on. But it's perfectly feasible to do that. Absolutely works. You're not tied into using the Pulumi cloud service. So the next piece is then pointing it at the Git repo. So this is the URL to the Git repo that I've got those files stored in. Give it the branch. I'm just pulling it off main. You can point to a subfolder. So there is another property there if you want to point to a subfolder within that repository. And then this destroy on finalize here indicates that if I remove the stack from Kubernetes, that Pulumi should go and delete the resources from Azure. Okay, so we're ready to actually run that now. So if we go over to our CLI and we are going to run the Kubernetes apply command, point it to that YAML file, and that should go ahead and create the stack for us. So that's done it. We can now have a look at the progress of this by looking at the stack resource. So if we do a get stack, that will list all of the stacks that are deployed. So you can see we've got one here, the one we just ran. And if we want to get more details, we can do describe stack. And this will give us some more information. You can see how it's set up and those sort of things, but the interesting bit is at the end here with the events and the status. So you can see at the minute that reconciliation is in progress, so it's running my stack file. So it's being processed, and you can see what's going on. You can see that it's looking at this commit file from Git, and it should be going off and creating my files for me. And if we just run that again, we should see some more information. There we go. It's now telling me that my stack has been successfully updated. And if we go look into Azure, and we'll have a look for the resource group, that should be called Operator Demo K8. There we go. And we should see in here we've got our storage account created. And there you go. And that's named appropriately. And that's all worked as I expected. We've gone back to our VS Code environment now. Let's go ahead and make a change. So let's add some more resources. Okay, so we're going to go ahead and we're going to add in a new virtual network. So creating a virtual network, giving it an address space, pointing it to go in the same resource group, and then using that config prefix to give it a name. Pretty standard, straightforward one there. So we're going to go commit that into Git. We'll sync those changes. And then if we go back to the CLI and we run describe again, Pulumi should detect that there's been a change. It's on the reconciliation loop. The default, I believe, is every 60 seconds it will check for changes. So we've just made that commit. So it should hopefully come up soon. There we go. So you can see it's now depicted that it has that new commit to add. It's gone back into stack processing mode. And it's reconciling that. So it's not ready yet. We can wait. And what we should see then is that VNet gets created for us. So there we go. It's now succeeded. It's processing complete. So if we hop back to the Azure portal and we refresh this, we should now see, there we go, we've got our VNet created. And that was all done without me needing to make any conscious effort to run that Pulumi code. It was all reconciled by the operator. So the process, all I have to go through here is to make those changes into Git. Git is my source of truth, as you would expect with a GitOps type operation. And when I make those changes, they will get pushed out. Now you saw there, I made the change, I committed it straight to main. Obviously, you generally wouldn't do that in a production environment. You would have a process where you would make a change on a branch. Maybe even you have a Pulumi operator and a Pulumi stack set up on your operator to do deployments on that branch to allow you to test them out. And then when you're ready, you make a PR, that gets approved, you merge that into main, and then the Pulumi operator picks up that change to main and pushes it out to your production environment, for example. As you saw when we created the stack, you can define which branch your stack is interested in. So you can have different configurations for different branches. Branches could represent environments, and you can be as complicated as you want within that. But you can see there the power of this Pulumi operator. It's doing all this reconciliation for me. Now, going back to our stack file here, there's one other thing we could also look at. So at the moment, the operator is only going to trigger when I make changes to my Git repo, which obviously sounds like that's exactly what you want. But what that won't deal with is drift correction. So if the only place people are making changes to my infrastructure is via the Git repo, that's great. You probably don't have to care that much. Everything was going through Git. Nothing should change outside of it. You're great. But what you might want to do is look at how you can deal with drift correction. So if somebody comes in, let's say they go into the Azure portal and they make a manual change to your infrastructure. Well, we don't want that. We want everything controlled this way. So we want it to revert back to the previous state it was as defined in my infrastructure as code. Now, in the setup we have here, that potentially will happen when you actually make a change in the Git repo in the future, and it may go back and make that change for you. But realistically, what you want is it to do that automatically for you, to revert any changes. And so you can have your stack do that for you and check on a regular basis to see whether any changes need to be made. So we can add some additional properties here into our stack file to make that happen. So the first one here is this continue resync on commit match. That basically says even if the Git commit that's deployed matches the Git commit that you've got from Git, you still want to run anyway. We want to set refresh to true. So this basically allows you to go and compare what's in the state file to what's actually in your cloud provider, in our case Azure. And then you want to set how many seconds it will wait between attempts to do this resync process. So the default there we've got set up is 60. You make that as long or as short as you want. Obviously, you don't want it too short because it's going to keep trying to do that over and over again while it's still doing a previous operation. And that's one thing to be aware of, is if there are multiple changes that Pulumi or the operator detects. So someone makes a commit to Git, and then very shortly afterwards somebody else makes another commit. It's not going to try and make both those changes at the same time. It will run the most recent one first and wait till that has finished before it then runs the second one, and so on. But we've made that change now to set those values. So we'll just go ahead and apply that change. If we go back over to the browser, and what we're going to do is we're going to make a change. We're going to add a tag, and we're going to call that drift value of a test, and we're going to apply that. And so you can see we've got that tag now set on the resource. And then if we go back and wait for this to run again, yeah, and you can see now that's now running a reconciliation again. It's processing and reconciling, and that should now be done yet. So if we go back over to the browser, and if we just click out and come back into this tags page, you can see that tag is gone because that wasn't configured in my code. Somebody had done that manually, so that's now reconciled that for me. So you can see that's dealing with drift detection. Now, you do have to be a bit careful with this. Obviously, if somebody's making manual changes, they're going to be overwritten, and that's probably what you want. But people should be aware of that. If they're testing out changes, maybe they've got this. I'm just going to test this out to make sure it fixes the problem, and then I'll put it into the Pulumi code. Well, they're going to have a hard time testing that out if it gets removed every 60 seconds. So maybe you don't want drift detection. Maybe in your test environments, given it's a per stack configuration, that's very easy to do. You have it off in test, and not on and on in prod, and you can have that configured. The other thing to bear in mind as well is policies. So if you have Azure policies that apply some changes to your resource, they are going to be constantly battling with this drift detection. So you're going to want to make sure that your code allows for that. So you can have Pulumi ignore changes. So maybe tags is one of those things. Maybe you've got a load of policies that apply tags to your resources that are outside of your control. And you can have Pulumi ignore changes either to all of the tags, or you can have it ignore changes to specific tags. So that isn't battling with policy, because otherwise you're just going to see it every minute. It's going to get tags going to get added, and then it's going to get removed a minute later, and so on. And you don't really want to do that approach. Okay, so the second option for deploying a stack is to do it as Pulumi code. And it's very similar to what we looked at in the Kubernetes definition, but a few tweaks we need to make. So the first thing first is around the secret. So if you remember, we created this secret here, which we're using in the actual Kubernetes manifest to point to the access token for Pulumi and the Azure credentials. When we do it with the Pulumi resource, we can't do it quite the same. We need to break them into two different secrets. So the first one we've got a secret for the Azure details, and you'll notice that the name of the secret values here have actually changed to match what the environment variable is. So before here we just had names whatever we decided on, because we could map those to environment variables in the Kubernetes manifest. With the Pulumi code, it's going to take them as the names for the environment variables, so we've changed those over to do that. We've included our subscription ID here as well, and we've got that secret doing that. Then we have a second secret that has the access token for the Pulumi Cloud service, and that's in a separate secret because we have to define that as a separate property on the actual stack resource. Then if we look at the actual stack object, this is how we define it, and it's a Kubernetes custom resource. Now, because it's a custom resource, there isn't a defined resource type for this in Pulumi. Instead, what we have to do is create one ourselves. So basically, we've created a CRD project and created these resource arguments, classes, that we will use to define what that class looks like. That is taken from one of the examples on the Pulumi site into how to do this, but effectively we're just creating resource argument classes that we can pass. If we go back to the stack, you see here we've got the type as a custom resource, and then we're passing in those stack args. So same sort of information we're providing. We'll come back to the environment secrets in a minute. We've got the stack name. Again, this is going to define which stack in Pulumi Cloud or in your resource provider use and what config file it's going to use. The Git repo for where the code's coming from. The branch we want to talk to, we're going to destroy and finalize again. And then we've got these two other options. And that's for ease of use, let's just move that to the end. So we've got this access token secret, which is pointing to a secret that contains the access token. This is looking for a single value for that in that secret. Then we've got this environment secret, which is a list of secrets, and we're pointing that at the secret we created above for the Azure stuff, and that will interpolate that into a list of environment variables as defined here. So all the same information we gave in the Kubernetes one, just defined using C# here or whatever your language of choice for Pulumi is, rather than using plain old YAML. So if we go back to our CLI, okay, so back at the CLI, we're going to run PulumiUP, and that should ask us to create 3 resources, the 2 secrets, and then the stack resource. And once that's deployed, it acts in the same way as it would have done had we deployed with the Kubernetes YAML file. They're the same once you've got the thing deployed. We'll go ahead and run that. And if we have a look, we should see that stack has been created. There we go. And we'll give that a minute, and that should reconcile, and we should have the resources created for that as well. And I say, after this point, you can treat them exactly the same. It's just how you define the stack within Kubernetes. In the first place, either option is fine. There we go, that's successfully run that stack processing, and it is now deployed as well. And that's it for today's session. Hopefully that gave you a good insight into what the Pulumi operator is, how you can use it to deploy your infrastructure in a GitOps type approach, and how it all hangs together. I hope you enjoyed the rest of the sessions at PulumiUP. Thanks very much for your time.